to mention that yesterday was the International Day of Women and Girls in Science. For those of you specifically who are directly involved in science, we wanted to say a happy day to you. And also would like to definitely thank all of our sponsors without whom we wouldn't be able to be here today. So thank you all of our sponsors, including Zendesk, that always provided us with the place and the food. There are a few announcements that I would like to make because I really think they are worth considering to register or attending. So the user conference this year, for the first time ever, it's going to be in Australia. So it's in Brisbane, 10th to 13th of July. So now is the time for early bird registration and abstract submission. There are some scholarships available that you can apply. And for the ladies, we are proud that we are actually sponsoring our conference for 2 scholarships. So if you are interested to apply, please consider to apply for the scholarships as well. There are also many tutorials always associated with Use Our Conference. This year is also, there are so many tutorials that you can apply for. And again, as Our Ladies group, we are offering a tutorial there for social network analysis as well. There is going to be Research Bazaar. I'm not sure if you have heard of this or not, but I would assume that this is very famous. So for people, specifically the students, researchers, and the academic people, for you to just get to know what tools would be necessary for you or helpful for your research, there's going to be a 3 days, free 3 days workshop when they tell you about a lot of tools that might be useful to you, from R&R Studio to MATLAB, Python, HPC, cloud computing, and a lot of those amazing things. Please consider applying for that one too. It's going to be in February later this month. There is also an Our Ladies directory. So this is something that's associated with the global Our Ladies around the world. So you can go there, write your name and your interest in R. And if you're interested to ever give a talk somewhere, just put your interest and then people can find you easily. We would love to have more Our Ladies in Melbourne involved in this website so we can find you much easier. So please do consider that. If you are a lady, if you like to share your R story or anything. But yeah, it's an Our Ladies directory, of course. So, and also, if you would like to get more involved with Our Ladies, we would love to hear about you, to tell us how you can get more involved. If you would like to give a talk, just approach us, send us an email, and then we can organize something. If you like to instruct something for workshops or help out with mentoring, if you like to sponsor the group, that's amazing. If you know of the sponsors that might be interested to sponsor our group or support us, please let us know. If you just have an idea and you think that will be useful for us to have it, just let us know. And anything else, we would be open to a lot of suggestions and feedback and anything that you might think would be helpful for the group as a whole. And then there is also the New Year survey. Believe me, this is very short. It's just 5 questions, and it would hugely help us to how program this year's plans. So what we can help, what we can do for you to make it a better group and more useful group. So this is a link here. We actually spread that through Twitter. You can find it on Meetup page as well, and we're going to email that through Meetup right now. Yes, you have it, that link. If you can do this today, that's amazing. Please do that. Yeah, now, right now. Maybe after the talk. Yeah. So, and finally, this is my great pleasure to introduce our speaker today, Belinda Maher, who started her journey in public transport in New Zealand, where she was doing she was involved in a very expensive project, about 2 billion or so, for train network in Auckland. And then she moved to Melbourne and got involved in public transport Victoria, where she used R as one of the tools to visualize and plot stop and stations and a lot of those paths in public transport. I should also say that she's currently based at Swinburne University, and her background is science, statistics, and operations research. So please join me and thank Belinda for joining us today. We can't wait to hear about that.
It'll just take me a second to set this up. So yes, I'm not actually from Auckland. I was born in Melbourne, but I lived there for 3 years.
Sorry about that.
No, that's all right. People always... So I'm not actually from Auckland. Yeah, so I just need to set this up. It's just gone blank on my screen. Yes, okay. Okay, so hi, I'm Belinda Maher. I work at Swinburne University at the moment on data which is unfortunately not about trains, which is a bit of a disappointment, but I'm coping. So yes, I used to work for Public Transport Victoria. I had a year-long contract there where I worked on some map data in R. Some of the graphs that some of the maps you'll see today are on my Tableau public profile because I use Tableau at Swinburne. R is much better, but for some things, Tableau is useful. So, so I currently look at student data, forecasting numbers of students, which is boring, but I'm going to start with a bit of a confession. I love maps. It took you a while to actually look at it. And I love trains. There, I've said it. So I'm quite fond of public transport maps. And so plotting maps in R is about transport is not something I ever thought I would get paid to do. So it was pretty sweet. So I got a job at PTV working in the operational performance analysis team a couple of years ago, where I drew some public transport maps in R. This one's actually in Tableau, but just because I hadn't done that one in R yet. So I used the geographical data in the publicly available GTFS dataset, so I'm going to talk about that. So what am I going to talk about? So what the challenge was with the data, what is GTFS, and finding the spatial data in a haystack, because that's really what it is. Avoiding duplication, so finding the right shapes to plot. Some other issues, if I get time, I'll mention those. The data's not perfect. So to help plot in Leaflet, you need to know a little bit about SP, the package SP, using spatial points and spatial lines objects. I did some cool maps in Leaflet, and I also recommend Google Way, though I don't think it's as pretty as Leaflet. So background. What was the challenge? So what is operational performance analysis anyway? What sort of data do we have, and how to best visualise this data? So you might recognise these creatures from train stations and on trams. So the team that I worked in at PTV crunches the numbers from the operator data sets. So the operators send in the case of train and tram, where all the vehicles were at certain times, and we compare that to they compare that to the timetable and calculate these stats. It's a SQL database. So I learnt a lot about querying SQL databases there in R. They also do some operational reports daily on the PTV website. So it's very exciting. You can see yesterday's performance the next day. But there's also, probably not exciting for most people, but politicians like it so that they can get other politicians in trouble. But anyway, so the track record data is also on the website, which is the monthly averages. So if you want some data to plot, go nuts there. It's not in a very pretty format, but yeah. So what sort of data did we have? This is the public version of the sort of stuff that we had. So not very exciting. PTV obviously have a lot of further detail underneath this. So in general, we had data like this, and PTV make graphs like this. And it's just like, you can't tell that, Almain is near, like, Belgrave and Lilydale, and there might be some tracks that interact. So it's not useful. So what we wanted to do for executive dashboards, which I know are the cool thing right now, unfortunately they're in Power BI, but I'm not fond of Power BI, but Power BI can actually run limited amounts of R sort of within Power BI. So that's one of the reasons why I tried to do it in R. So what did we actually want to do with this data? This is just a little something that I got together last weekend. So this is the tram. So this is data from. So I should talk that way. So data from the website with the times. Sorry, the actual data, and I've taken the GTFS data and I've just put a colour depending on how the tram line was, how that particular tram line was running. So if you plot the data this way, you can see more that trams in the west that don't, especially the one that doesn't go into the city, runs on time. So it's sort of, you can get a bit more information. And the 86 is really bad. My friend who drives on the 86 says it's not her fault. Yarra claim it's the E-Class's fault, but that's another story. So that's a little bit better. But what we really wanted to get to was something like this, where we can see, so this is the Alamein line. I just picked it because it's short and I know most of the stations. So here I've actually split this line data between stations, because for trains you generally have timing data actually at every station. It's most stations, but so the sort of visualisations that PTV wanted to do were ones that could actually show the data in space as well as what the data was. So this was sort of what we wanted to get to. So I'll just quickly mention timing points, because with train, this is probably boring detail, but with train you'll have timings at stations. With tram you'll actually have timings at AVM signposts, which are these really old radio towers that are literally from the 80s, which sort of ping the tram as it's going past. So so you'd need to split the tram lines by where they cross these timing points. And buses, they sort of have artificial timing points. The bus tracking is actually done with GPS data. And I'm not sure about V-Line. I think it's GPS and manual. So I talked about splitting the data into different sections, and so then colour them differently to show the data. So when I actually did this in R, this was my first go at it in R. So this is using Leaflet, and so that's what I'll be talking about, how I sort of organised the GTFS data so that I could do that. So GTFS data is not really intended to be used for this, so it was a bit tricky. So most of the talk is about the things you need to fix about GTFS to actually use it. So on GTFS, I'll mention what it is, picking out duplicates, checking that you have the full line, and splitting the line into those sections, and then labelling those sections. Don't worry, I won't go into detail. So what is GTFS anyway? It's the Google Transit feed specification, or it was. It's an open standard for publishing public transport timetables, stop locations and transport path information. So it's been around for a little while. It's been renamed as the General Transit Feed Specification. And PTV first published a GTFS data set in 2015, so we haven't had the data for very long. I put in this lovely picture because it shows how the different files connect, because the data is actually quite complicated, so I thought that was a really neat way of showing the data. So what is GTFS designed to do? It's designed to send you to where you want to go when you're using Google Maps. So it has all of the timetable data and some path information, and it allows you to do things like this. Say if I wanted to go to Zendesk from Zendesk to the Epworth, I always opening Google Maps to do this sort of thing. So there are some little issues with it though. You see, this is a train line, and the train doesn't actually follow the road. So Google do some strange stuff to it. That's not in what PTV have given them. That's another error. So where do I get this data? If you Google it, you'll find on the PTV website a really, really old version. I only recently discovered that you can actually get the latest version just at /downloads/GTFS, so that's good to know. So it's made up of 8 files with different data in. Luckily, we don't need all of them. It's mostly shapes and stops that we need for drawing maps. So this is similar to the previous diagram, how the data works, but I won't go into that. So you can sort of join up using particular ID fields between the different files, but it's not sort of really designed to approach it from this angle. It's designed to go from, I want to go from this place to this place, find me a vehicle that does that, and then find me the path that goes that way. So if you just want to say, hey, give me all the paths, it's not as easy. So the trouble is duplication. So this is my first attempt at, I'm going to have a look at this data, and I was very new to R at the time. I finally got my ggplot2 happening, and it took ages to graph, and like just figuring out all of that was just like, oh, and then it's not even that pretty. Similar for, sorry, that was train, this is tram. So it's a bit of a pain to go back into the code and rezoom the map. Takes ages to plot. So I was like, why does this take so long? Is it because I'm doing it from Power BI, or, no, because it takes just as long straight in R. So then I looked at the file sizes. So 10 megabytes of tram. These are just little points. It's not like, minute detail. It's not a, very high res picture. The train data is 31 megabytes. So when you take out all the most of the duplication, you get it down to 120 kilobytes, I think. So yeah, I had a bit of a eureka moment on how to show you part of what the problem with the duplication is. So sorry if you're not familiar with the Alamein line. This is all sort of PTV speak, but so if you were an Alamein train, not all Alamein trains are equal. They don't all go from Flinders Street to Alamein. You might go clockwise around the loop, you might go anti-clockwise around the loop, you might decide, no, I'm going to start from Riversdale instead. So these are all sort of valid paths in the data, but then you also have multiple copies of each of these, and these are just some of them, there's more. So that's part of what the problem is, because it's just not designed to do what I did with it. So also PTV don't seem to have altered the trip head sign field, which would help, because if you were a train, so I think what trip head sign is supposed to mean is, like, if I'm a train going to Riversdale from the city, the passenger information says Riversdale, it doesn't say Alamein, even though it's going on the Alamein line. So there didn't seem to be further data, sort of hidden away labels within the data. You don't have useful labels on the data for those shapes. So I stumbled upon a quick-ish way of solving the problem, which caused other problems, but we'll talk about that. So in the shapes file, there is actually a field called shape distance travelled. So it has for each of the points, it has how far along the line you've gone at that point. So if you just take the maximum, so for each shape that you've got, for each shape ID, you take the maximum shape distance travelled and you've got the length of that shape. So that was a quick way of doing it, and that's how I did it. So that seems all well and good. Go through the data, find the longest shape for each line and plot it. But now it's time for questions. What's missing if you plot just the longest line in the data? No train nerds in the audience this evening.
A start point?
Well, this is just everything. So this is well, it's not everything, but it's just a line for every single route. So if you... No, Jollymont's there. You need new glasses, Simon. So if you look... be able to do a little laser pointer so you can see that. So, look at me with my technology. So if you were coming from North Melbourne and you wanted to go to Flagstaff, where's that line? And if you were coming from Richmond and you want to go to Parliament, where's that line? So that's, if you take the longest line, you're just going to pick the longest way around the loop. So you're not going to have every option. So if you're not mapping the city loop, it doesn't matter as much, but it's incomplete. So yeah, if you actually take all of the data and colour it with the different, this has just got the different routes in different colours, well, the different groups. You can see, so I've got 2 of the missing lines, but then there's also going around the loop from Flinders Street to Parliament, or going from Jollymont to Parliament. Now, they're actually in the data as just 90-degree angles, so they just haven't bothered putting that data in, which annoys me as a map nerd, but that's that's just I think. The other issue with the taking the longest line is that there's an express line from Laverton to Newport, which I totally forgot about because I've never taken it. So in the bottom in blue is my leaflet map, and it's also missing one possible path. So that's just showing that it doesn't. Taking the longest line doesn't solve everything. You've also got to clean up a couple of little things. So in order to split the lines at stations, I did look into using sort of fancy spatial functions. How am I going to do this? And it didn't sort of work very well. But then I actually looked at the data and I saw that it's already cut at the stations, but just not labelled. So you'll see that in the next slide. So I figured out where the stations were, and I allocated different section names at each point where there was a duplicate point. So it looks a bit like this, which is a bit boring, but so if you see, so you've got shape ID and the latitude and longitude, which define the point. You've got the shape point sequence, which says I'm going to draw these points in an order and they're going to make a line, and the shape distance travelled that I mentioned before. So this is just taking an Alamein line, and so I went through and I actually had to name, so these are those station codes, I actually had to name the stations because this is what we would have needed to actually do a dashboard with this to assign the right data to each bit. So I sort of finished this off, this project off myself because my contract ended, and they didn't have any funding. So ideally, just a point that you could sort of set up a network graph to be able to sort of efficiently plot them, but I don't really know anything about network graphs. So, so the next point is spatial data in R. So I'm by no means am I an expert, but this is just a quick, a few bits and pieces that I use to plot some data. So this is actually a leaflet map as well, and just showing what the network map actually looks like physically. I think it's pretty, but I'm a nerd, so. So this SP library is for spatial objects. So that's a way of sort of encapsulating your latitude and longitude into an object in R, which makes it easier to feed to other packages. So there are three main types of spatial data. There's points, lines, or polygons. So in the case of so points and lines are fairly obvious. Polygons are kind of like a line that joins up again. So you can graph things like suburbs. You can draw a polygon of a suburb, but there's no polygons in this data. So how do we put data into spatial SP SP objects? So the location of the stations is a spatial, you can put that into a spatial points object. So if you read that data from GTFS and it's just a CSV, and this actually doesn't have any duplication in it, this one, it's just the stops. And this is what the fields look like. And so you just chuck the latitude and longitude straight into a spatial points object, and you have to give it a projection, which, yeah, I spent a lot of time having to figure out what all this meant, but this is the rough guide. So for a polylines, a path, so as I said before, it's a collection of points that are joined in an order by a sequence ID. So if you load metro shapes, you get you get your latitude and longitude and the ID of the shape, but you also get the sequence of that shape. So, and the shape distance travelled that I mentioned before. So we need to read the points and sequences in to a spatial lines object, but this is a bit trickier because you've got multiple lines and you need to sort of label them properly. And so I found a function that someone else had written to do it for me, which was good. So I've got a link down the bottom. There's just an rpubs function that goes through and puts all that spatial data into a nice tidy spatial lines object. And then if you check class of metro lines, yes, it's a spatial lines object, so yay. That function will just give the lines names 1, 2, line 1, line 2, so you can go in and name them to make it easier to deal with them. So plotting with Leaflet. This is, I wasn't directly asked to do this at PTV, but I did because it was useful for what I was doing, just to check the data. So this is all of a zoom of all of the stations on the train network, and if I might be able to show you. Sorry about this. So this is what it looks like, and compared to those ggplot2 pictures, being able to zoom in and look at Mooney Ponds if you really want to, and check the data was really helpful to be able to just get your hands on the data for checking. So that's why I thought Leaflet was really cool. So you also find some issues with the data, but that's me being a little bit OCD about maps again. So, so I'll just go back. So this is really. So this is very rough Leaflet syntax. So Leaflet plays really well with Magritte, so it's worthwhile learning how to use it. I kind of learnt Magritte because I'd used it in Leaflet, and now it's like really, really handy for work. So, so the general gist of it is you call Leaflet with open and close brackets, you add some tiles, you can add some markers for your points, and I'm not sure if they actually have to be in a spatial points object. And you can then also at the bottom add some polylines, which are which is your line data. So something I found useful working with Leaflet, I know this is quite unreadable, this code, I was working on it this afternoon. So to start off with, you get a default base map, which I thought was ugly. I think it might be an open data map. So I stumbled upon this other one with the grey background, which I think is much clearer for this kind of map. So to draw on those map tiles, you might have noticed when I zoomed in on the Leaflet map, it's refreshing the map tiles as you zoom in and out. So it will have so the tiles are the little sort of pictures of data underneath of roads and what have you. So it's resizing them for you, so you get the best detail. So this is just how you would change that background map. So you can put your little calling leaflet and your nice sexy map tiles into empty map, and then you can call empty map and add some circle markers and put that into main map. And I just found that was an easier way of just adding little layers as you went along. So adding polylines, this was just a little test I did, just adding colours, and I'm like, oh, I don't really need to add colours to this, so I'll just stop now. So you can actually reference particular lines in your Metro Lines data spatial lines object and give them each a particular colour. So I've given the Alamein and Lilydale or whatever it is, I've given them both yellow because they're in the same group. So then when you have a whole lot of different little subsections of your line, you can use our colour brewer to get like a list of colours if you just want to do a scale. But if you wanted to actually put data in it, in terms of like the tram data that I showed before, you can sort of loop through using that Alamein map kind of object that you created before and just add one line on it each time with a different colour. So there just happened to be 17 sections in this. That's why probably not the best way of doing it, but it works. So this is a close-up of what I managed to do with splitting that data as I'd been asked to. So it's obviously dummy data. So if we can... My mouse seems to have died. So similar to the other one, but you can see that the line changes colour at the stations. So that's what my boss wanted me to do, so I did it. It's his problem if he wants to use Power BI for it, because Leaflet doesn't work in Power BI. So, but that's another story. I also did this map in, I did the map in Tableau to specifically to send to my old boss and say, look, Tableau is so much better than Power BI. He didn't bite. I was disappointed. Yeah. Anyway, so okay. So Google Way is another option. I only heard about this after I'd finished at PTV. There was an our users group talk about it with the developer. It was developed in Melbourne. And so it has a similar sort of syntax to Leaflet, where you sort of build up your map and you put markers on it. I personally don't think it's as pretty as Leaflet, but it sort of does similar things. And I think you can chuck, you can also chuck like line data in there without it being a spatial points object. Spatial lines object. It gets confusing. So that's a little blurb about Google Way, and so that presentation is still online. And yeah.
With Google Way, so
Yeah.
Can you just download the data, for example, which
Oh.
already in a structure that you can use it something else?
No, well, Google Way, it has a whole lot of other things that it can do, like, it can do heat maps, it can do, you can sort of draw, what are they called? I think it's called a choropleth or something, where you draw different polygons in different colours. So, for example, with suburbs, showing different data from different suburbs. I think they do have some. I spoke to the developer, and I know he'd been doing some work on GTFS data as well. So I think he actually has a little bit of GTFS data in there. Just like I think he has at least some tram stops is one of the examples. The example that I did was actually, I actually used train stations because I was getting a clash between the tram _stops name when I was doing this map earlier. But so it's more. I think it's more for mapping than actually data.
In the data.
Yeah.
You can only use it and it gives you plots. Like you just
Yeah, similar to Leaflet. You've got to send it the data, but you can also do things like you can encode a polyline into a string and then just send the string, but I think that's lossy. And yeah, so I haven't really looked at it very much, but it is cool and it can do some cool stuff. But I was looking the other day and I didn't like the markers on it, so because at least I prefer the circle markers in Leaflet. But you can, I think with both of them, you can pick an icon and use that instead and sort of put that onto your map. But you sort of, when you want to know exactly where something is to check the data, like a cross would be better. So yeah. So that's kind of it. I've also mentioned, there's a good intro to spatial data in R, which if you Google that, you'll probably find it, and that sort of goes through spatial points. And don't be surprised if your head kind of explodes a bit at the thought of it. But you can do some cool stuff. So welcome to take questions. I wouldn't say that it's good for maps. I had this challenge of like, can I put this data in Tableau and map it, because I use Tableau at work, and it's kind of good for just doing a quick graph, because you don't sort of have to go through the hoo-ha of kind of finding the, each variable, especially as I'm often looking at data at work that I don't know a lot about. So it's like, I have to pull in this particular field. And so it's good because it's sort of got a list of the data source that you've connected to, and it's just drag and drop. So it's limited in what it can, what editing you can do of the data. There's some stuff you can do, but actually, like my biggest project at Swinburne, I just pulled the data out from the database, munged it in R, and then fed a CSV file back into Tableau because it was easier. So, yeah. I don't think, like, the ggplot, I don't think it's very pretty when it was like, I saw a Leaflet map and I was like, whoa, I can interact with this. And you could do crazy stuff with, like, you could set up Shiny to be able to select, actually on the Tableau maps that I've done, one of the good things about Tableau is you can go, let's find one that's actually been done in Tableau. You can actually go and set filters. You can publish your data and the user can interact with the data, like turning filters on and off, and you can limit how much control they have over it, so that it's sort of good for that kind of thing, but it's not a programming language. It's not, and like, actually what I did with the tram data was I didn't use the filtered, I hadn't filtered it, and so it's huge. And then I, did all these joins to try and get further information on it, and it was just like crashing my computer. So yeah, Tableau, it's useful for some things, but it's not, it's kind of, because I work in a business analytics team and they do dashboards, so it's kind of useful for that. Being able to both edit the data, so edit the data and filter the data, and do a calculation of what's the maximum line length for each line. I think R is very powerful once you know how to use it, whereas I don't know, I'm not really a fan of sort of dashboards, because because they often, those sort of dashboarding programs, they're more about like, let's make a sexy dashboard, and it's not about let's actually do some useful stuff with the data. So.
One comment I would make, so somebody said that you kind of have the same thing where Math is beautiful with
Yeah.
our personal computers.
Yeah.
But we have no way of sharing.
Yeah. So I mean, that's why Power BI and Tableau are so popular, because they enable that sharing. And so I have used, I don't generally make dashboards for sort of public consumption at Swinburne, but it is cool that you can sort of, it's a similar thing publishing to Tableau Public, and sort of just being able to put your data there, and you can even, make it so they can interact with the data, but they can't actually see the data behind it. And so you have control over what they're doing, but the user experience from a sort of developer point of view, I don't think is very good often with, so does that kind of answer your question, or is sort of, yeah. What sort of leaflet maps do you draw? Yeah. Did I say it right? I just cannot say that word. Tablet can do some cool stuff. I think I did actually, just because I'm tragic, I did like throw some ABS data into Tableau. Actually, one of my colleagues, Justin Kelly, if you search for him on Tableau Public, he's done some maps of the same-sex marriage postal vote results by area. So it's, he said it's very quick to chuck that data in. So I think that's kind of the good thing about Tableau, is that it can be quick to just get a rough thing together, but really you're going to have a lot more control. You can write custom SQL within Tableau, so that's good, but it would I would be happier if they just made their joining better, so you didn't have to do a custom SQL. So yeah. What I did when I showed those HTML files before was, so I just I just ran the code in RStudio, opens up in your little plot viewer, and then you can save as HTML there. And so that's all that was. It was just an easy way of me not having to find the code and rerun them. It's like, okay, I've got this saved as HTML. So then you could, and it works. So you need a internet connection for the background, the map tiles, but the actual data just all sits there in, so they can be a little bit big. I think maybe the whole system map that I did was maybe a meg or two, so it can kill your Chrome memory, but you can do it, yeah. So. Yeah. Well, you would think that there would be heaps of packages in R that deal just with GTFS data and just do all of this stuff for you. But no, I've looked. There's some stuff. Yeah, I haven't written them yet. Yeah, clearly. There's a JavaScript little schedule viewer that I think Google have published, so you can sort of see the trips like that, but. Google, the problem is it's just really not user-friendly. Originally I was going to sort of show the data and you just would have died of boredom. It's just all these crazy ID codes and which don't mean anything. There's just like, 20 different versions of the Alamein line and yeah. So there are a few packages around, but some of them weren't in R, and so I haven't really looked into them in huge detail, but yeah, there definitely should be. Yeah.
So please join me in thanking up with the So thanks everyone. We will have probably I think 10 to 15 minutes if you want to just socialize a little bit, and then we all go home. Thank you for joining us. Thank you so much.